I'm Nadja Swart for BizNews.com, and with me today is Dr. Thomas Seyfried. He's a professor at Boston College and a prominent researcher in the field of cancer biology and metabolic theory. Dr. Seyfried, it's really a pleasure to chat to you.
Well, thank you very much, Nadia. It's nice to be here and speak with you as well.
So, I can hardly believe my luck. I mean, this never really happens, but an international team of researchers had a study that was reported on today, and you were one of the co-authors, which found a non-toxic combination pairing a specialized diet and a tumor-fighting drug, which destroys two major cells in an aggressive glioblastoma. It's an aggressive brain cancer. This is groundbreaking. Can you talk me through the study, the findings?
Yes. Well, we know brain cancer, especially glioblastoma, is like one of the worst, if not the worst, type of cancer that a person can have, and also little children can have pineoblastomas. They're very similar, except they occur in a younger brain, but their outcome is just as devastating. What we have identified over many, many years of research based on Otto Warburg's original observations, all of the different neoplastic cells inside of a glioblastoma are predominantly using a fermentation metabolism to generate energy. And what that essentially means is they generate energy without the use of oxygen. And what they call they used to call it glioblastoma multiforme, because this types of cells that were in there were always so complicated and dysmorphic and all this kind of stuff. And, many, many studies have shown hundreds and thousands of gene mutations in all these kinds of cells. But according to our metabolic hypothesis, the mitochondrial metabolic theory of cancer, the origin of the disease arises from damage to the respiration of the cells, and all of the cells then would have to ferment, that is, generate energy without oxygen, regardless of what the cells look like. All the neoplastic cells in the glioblastoma are using energy without oxygen, and that comes from just two fuels, glucose and glutamine, the sugar glucose and the amino acid glutamine. One of the problems with glioblastoma, the horrible, horrible survival statistics, which have not changed in almost 100 years, if you can believe this. When you think about all of the accomplishments of humankind in the last 100 years, astonishing advances in science and technology, a Webb telescope that orbits the Earth 1 million miles and can look at the origin, and yet we have not made one major advance in keeping people alive with glioblastoma. Can you believe this? And one of there's a couple of major problems with this. One is the misunderstanding of what cancer is, and including glioblastoma. It's not a genetic disease. It's a metabolic disease. That's number one. Number two is the continued irradiation of the brain in people that have these tumors. And we have published very, very clear evidence that when a person is diagnosed with glioblastoma, the radiation of the brain frees up the two fuels, the metabolic fuels, the glucose and the glutamine, needed to drive the growth of the tumor. So the very process of treating a person it's bad enough that the person has this tumor. It's worse when you treat it with a therapy that frees up the two fuels that drive the tumor, leading to the rapid death and demise of the majority of people that have these tumors. There will be no advance in managing glioblastoma until we stop irradiating the brain of people that have glioblastoma. I have published, and my colleagues have published papers upon papers showing the details of what I'm saying, yet for whatever reason, it is ignored by the scientific community. I have no idea what could account for someone to use a therapy that would lead to the rapid demise of their very patients. Yet we have shown when you irradiate the brain, you free up the two fuels that drive energy without oxygen. That is the sugar glucose and the amino acid glutamine. The glucose, listen, when you irradiate somebody, blood sugar goes up high, and the head begins to warm because of the radiation. So you give high-dose steroids, which make blood sugar go even higher. The radiation breaks apart these very intricate cell connections between neurons and glia, freeing up massive amounts of glutamine. It's unbelievable. And then these poor folks are all dying. The death from glioblastoma is so reproducible in every major medical school throughout the world. It's unbelievable. You cannot design a more perfect experiment to lead to the demise of your patients than the current standard of care for glioblastoma. I have no clue how the words that I am saying are completely misunderstood by anyone treating patients with glioblastoma. It's unbelievable. So we have a person that chose no radiation, no chemo, none of this. And he's still alive in England, Pablo Kelly. He said, I don't want radiation, I don't want chemo, I don't want any of this stuff. He had surgery. We think surgery is an extremely important tool for managing glioblastoma. Because if you can get rid of the tumor, debulking, we call it debulking. And metabolic therapy can shrink the tumor, so surgical debulking becomes even more effective. So we think surgery is absolutely essential for the management of glioblastoma, if done correctly with metabolic therapy, a therapy that restricts the availability of the glucose and the glutamine, does not disturb the tumor microenvironment. So we can shrink it down, reduce the inflammation. Surgery can take the majority of this tumor out, and we think patients will live far, far longer than they do today if they do things the correct way. First of all, you have to realize it's not a genetic disease, so get over this crazy stuff about trying to target mutations and all this stuff that's based on a wrong theory. It's a metabolic theory. It can't live without glucose and glutamine. And they also can't use fatty acids or ketone bodies. So a successful management for glioblastoma becomes transitioning the patient over to nutritional ketosis, lowers blood sugar, elevates ketone bodies, which the tumor cells cannot use, so you marginalize them, and then you come in with drugs and procedures to target glucose and glutamine. This will allow patients to stay alive 2, 3, 4 times longer than and with a higher quality of life. Why is this not done? We have to start asking the medical community, why is this not done? And that's the great mystery. And if people want to challenge this, all you have to do is look at the survival statistics and understand the metabolism of cancer, and you will understand why your patients aren't surviving.
It seems to me from what you're saying that cancer is an environmental and a lifestyle disease.
Well, I mean, there's no way, we don't know what the cause is of glioblastoma. It could have many, many different causes. So it's not a lifestyle issue with respect to its origin. It can be a lifestyle modification once the tumor is diagnosed. So the origin of glioblastoma can come from viral infections. It can come from trauma to the head. It can come from exposure to chemicals. It can come from a lot of different reasons. But once you have that diagnosis, then there becomes a clear strategy for managing that cancer. Very, very different than what we're doing to these patients today.
Well, you mentioned that it can be treated with metabolic therapies. Ketogenic diet, as far as I understand, is one of those. What are the metabolic therapies and what do they entail?
Well, the ketogenic diet or calorie restriction or say water-only fasting, any of these procedures, what they do is they lower the blood sugar that's needed to drive the tumor. They're also powerfully anti-inflammatory. So many of these cancers are loaded with tremendous amounts of inflammation. The microenvironment is inflamed. All of that stuff can be significantly reduced if people say, well, water-only fasting, who can do that? Well, you have a choice. You can either do that or you can die from the tumor. Yeah. I mean, you don't have many options. But on the other hand, a calorie-restricted ketogenic diet or any diet that lowers blood sugar and elevates ketones, which we have shown, we've actually developed the glucose ketone index monitor to allow cancer patients, not only glioblastoma, but almost all cancers are very similar. They're all fermenters. They all need glucose and glutamine. You have a meter that can be used, the Keto Mojo meter, that can be used to tell a cancer patients how low their blood sugar is and how high their ketones are. And when they get into a particular zone, you're going to be killing tumor cells. Once you get into that zone, then we use glutamine targeting drugs. As a matter of fact, one of the big challenges in managing brain cancer is delivering drugs through what we call the blood-brain barrier. When you put a patient into therapeutic nutritional ketosis, you can easily deliver small molecules to the tumor. We publish papers showing this. You don't need some fancy chemical. You just have to put the patient into therapeutic ketosis and then deliver glutamine targeting drugs, small quantities of these. You don't even need a lot. Very small amounts of these drugs will be massively effective when used with ketogenic metabolic therapy. So it's a diet drug synergy to manage these cancers without causing toxicity. It's a nice thing too. You don't have to have your hair fall out. You have to have all these horrible nausea and vomiting and all this kind of crazy stuff. You can actually manage the cancer. I mean, yes, you'll feel hungry on occasion, but your body gets to adjust this. It adapts. You adapt to this, and the tumor cells get hammered, and they start shriveling up and dying, and the patients live a lot longer with a much higher quality of life. And this will be the future. It just takes time for people to understand what I'm saying.
Just before we go further, I'd like to understand these two sort of conflicting theories of what cancer is. What is the prevailing genetic theory of cancer as a disease, and then the contrasting mitochondrial metabolic definition of cancer?
Yeah, well, I mean, right now, if you go to the National Cancer Institute in the United States, which is part of the NIH, National Institutes of Health, it says right on their website, cancer is a genetic disease caused by mutations. I mean, nothing could be further from the truth. It's just a dogmatic ideology. It's a silent assumption that has been driven into the brains, not only from the NCI, but also throughout the world. You go to England, Germany, they all think cancer is a genetic disease. I mean, we have clearly shown through nuclear transfer experiments. I summarized dozens and dozens of experiments showing that the mutations in the nucleus cannot be the drivers of dysregulated cell growth, which is cancer. Then they said, well, we only have to these driver mutations are the ones that are responsible for this. They even termed it's not all the mutations are bad, only the drivers. Well, now we're realizing all of us have large numbers of driver mutations in cells that never become cancer. So clearly this, and also, cancer is more of a modern problem than it was in the past. Aboriginal tribes and was very rare to find cancer in any of our humans that followed traditional ways of life. Our closest relatives, the chimpanzee, they never documented a case of breast cancer in a female chimpanzee. Yet breast cancer in the United States has now replaced heart disease as the number one killer of women. So clearly the genetics of the chimp and us are almost the same. Our Aboriginal ancestors are the same as us, and cancer is extremely rare. So it's an environmental problem. The mutations actually come. This is where we need to know what the mitochondrial metabolic theory is, which arose with the work of Otto Warburg. So when mitochondria become damaged, they throw out which we call ROS, R-O-S.
What are mitochondria?
Oh, well, we have a cell. Yes. All of the cells in our body contain a nucleus that has largely our genome. Most of our genome is in the nucleus.
And nucleus allows reproduction.
Yes.
Bacteria don't have nucleus.
Yeah. So cell division is needed. The nucleus is separated, and we remove it. So, absolutely, you have a nucleus, but you also have many other organelles. You have various kinds of membranes, lysosomes, but the main organelle is the mitochondria. This arose from an ancient bacteria that fused, I don't know, maybe it was, I think, 8.8 million years ago, just when oxygen started to come into the atmosphere, some 2.5 billion years. It allowed cells to form multicellular organisms. Okay, multicellular organ. Before that, everything, we all existed at one point as a single cell, living in a hypoxic environment. Can you believe this? I mean, even the smartest people and the greatest people in the world all started off as a single cell at one point in our existence on the planet. Even Warburg said the great Einstein started off as a single cell. So at that time, there was no oxygen, so they just divided like crazy. And it wasn't until oxygen came into the atmosphere and was able to be captured by another kind of bacteria, which was the origination of the mitochondria. So the mitochondria is like another organism inside the cell. It has its own DNA, and it is actually the controller of our existence on the planet, the mitochondria. It regulates energy metabolism inside the cell. So the cell knows what to do when it needs to do this, all driven. And the nucleus is kind of a slave of the mitochondria. The nucleus pretty much does whatever the mitochondria thinks should be done. So when the mitochondria become dysfunctional and inoperable, the cell reverts back to its ancient ways of dysregulated cell growth. And in order for it to grow that way, it has to ferment. It uses fuels that don't require oxygen. And we and others have shown those fuels are glucose and glutamine. So in the very earliest existence of life on Earth, there was fermentation. Fermentation is the ability to get energy, ATP, without oxygen. And all of these cancer cells, whether it's a glioblastoma or lung cancer, colon cancer, breast cancer, bladder cancer, they're all using a very similar common mechanism, energy without oxygen, fermentation. So you say, what can they ferment? And we and others have shown it is the sugar glucose and the amino acid glutamine. So if you want to kill cancer cells, you must deprive them of their fermentable fuels. And the strategy that requires this is based on the mitochondrial metabolic theory of cancer, not the somatic mutation theory of cancer. So once you know that cancer is driven by fermentation and the origin of cancer comes from damage to the organelle mitochondria, then you know how you should be managing cancer. You have to transition the whole body to a fuel that the tumor cells can't use. They cannot ferment fatty acids or ketone bodies. They can ferment only glucose and glutamine. It's not that complicated once you understand the global issues that you're dealing with. People just want to make everything so complicated, and they're all working under an incorrect theory. And if you're working under an incorrect theory, you're never going to achieve the outcome that you would have expected in the first place.
There are two sort of anomalies here for me that just completely conflict with what you just said, and that's one of them being that the general approach to cancer is that every cancer is different and it needs to be sort of fought on a case-to-case basis.
Yeah, that's incorrect.
Yeah. The second just sort of big red flag is that a focus on ketones and ketogenic diet and just behavioral modifications in terms of lifestyle and environment and those kinds of things have been successful in reversing type 2 diabetes. Doctors like Dr. Chris Palmer also believes that mental illness is a metabolic illness. So it feels like there are just so many signs going in this direction, but that leads me to what you were sort of just questioning earlier, which is if it's this obvious, why? So you must have some theories. Health authorities are lauded for, fighting cancer, winning cancer. This is how, in what way is this happening?
Yeah, you're right about that. I think you have to look at the institutions that are, dependent on cancer being a metabolic disease. Well, correction. The institutions that are dependent on cancer being a genetic disease.
Well, it's $1 billion industry.
Yeah, it's a big industry. And I know to transition from what we're currently doing, which is largely ineffective, to what could be remarkably effective, it will take some time. But, to this transition then, so to take time to understand what I'm saying and adapt it to the clinic, unfortunately, we have to sacrifice so many cancer patients. People that could be alive and doing well, we have to let them die miserably, only because it takes a while for the institutions to readapt themselves and say, well, I'm sorry, we just have to let all you folks die because we're not really geared up to treat your disease the way it should be treated. We've invested billions and billions of dollars into chemotherapies and all these technologies and immunotherapies. They're all based on the somatic mutation theory. And if that theory is incorrect, the outcome may not be good. Now, the idea is that, we have some people that survive massive doses of chemo and radiation, and we have some people that survive these immunotherapies. But we also have many, many, many people dying from radiation and chemo, and we have many, many people dying from immunotherapies in the form of what we call hyper-progressive disease, where the treatment actually kills the patient before the cancer does. They die from the complications of cancer. What does that mean? Well, they probably killed the poor patient with the therapies. You should never, ever have to treat another member of our species with anything that has a remote possibility of killing them in the attempt to make their health better, right? It doesn't make any sense. Rarely do you die from a low carbohydrate, high fat diet taken in small amounts. You don't die from that. I don't know anybody who's died from that. But you struck a nerve there. And you have to ask folks that are irradiating people and you treating them with very toxic drugs, why are you doing that? What is oh no, this is what we all do. Well, you just have to do it because everybody else is doing it? You have no functional brain cells? You can't look and see that this may not be working well? So I look at this and I'm saying, it's going to change. Yeah, absolutely will it change, because we're not going to continue to do this crazy stuff for another 100 years. We just can't allow all these good folks to be dying and poisoned, irradiated, suffering miserably, surgically mutilated. You can't believe the horror stories that are going on in these cancer clinics, treating people. It's almost medieval in what we're doing to these poor folks, only because we have a business model in place that can't change. So anyway, it's got a lot of things going with it.
It's a very systemic problem, I think, because, to what extent are the doctors not allowed to be open with their patients about alternative treatments because of, pressure on them?
Yeah, well, I think that's an important point. I think there has to be some flexibility. Right now, the AMA, American Medical Association, in fact, it's not only AMA, it's everywhere. I don't find, everywhere I go on the planet, they're doing the same kinds of crazy stuff. It seems to be some sort of, an effect on the whole institution, why you have to do this stuff no matter. You go to South Africa. They're doing the same thing there that they are doing in Dana-Farber Cancer Center here in Boston, or MD Anderson. They're all doing the same kinds of crazy stuff. Everybody's trying to gene sequence stuff. Everybody's looking for signaling cascades and and I said, well, you pull the plug on their fuels, they die. Well, you have to worry about all this other stuff. What are you worried about all this kind of crazy stuff for? If the cell dies and the patient is healthy and looking good, why are you worried about all these minutia stuff? And so there's a lot of issues here. It's that we have to come to realize. The most important thing is to recognize that cancer is a mitochondrial metabolic disease, and we're correcting Otto Warburg's original observations, showing where he was correct and where he was not correct. We're polishing up that whole concept. We're going to come out with a major paper showing how Otto Warburg was in fact right about the origin of cancer. Unfortunately, Warburg never knew or wasn't able to take his knowledge and develop it into an effective therapeutic strategy. So we're doing that. So we're cleaning up Warburg's ideas, showing where he was right and where he wasn't, and then we're developing a therapy based on that. And that will eventually become the standard of care for cancer.
What was his theory on the origin of cancer, which you say remains?
Yeah, what Warburg, a very interesting character, Sam Apple just wrote the book Ravenous, that describes Warburg's. I mean, he was an interesting character. It was from his work from the 1920s on, after he got out of the First World War. Oh, yeah, you should read the story. He was a aristocratic German from the Prussian area of Germany. And his whole history of friends and family were all of these very successful businessmen and scientists. But he knew early on that cancer had a very unique metabolic phenotype. They fermented. The nice thing about the interesting thing Warburg clearly showed, I mean, if you took a rat with a tumor on its body and gave the rat cyanide kills people real quick. You take cyanide, you're dead within 1 minute. But the rat died instantly, but the cancer cells were fine. So they don't need oxygen. That's what I'm saying. These cancer cells can live in cyanide. Yeah. So if a person were to have a tumor in their body, and they would say, well, I don't want to live on the planet anymore, I want to take my own life, they would take the cyanide. They would be dead, but their tumor would be fine. I know it's nuts, right? It sounds nuts. But Warburg did some of those experiments years ago. And that told us right away that cancer cells don't need oxygen for survival. So what do they need? And they ferment. And he said that. And then the gene crazies got involved with this. And they said, oh, no, it's all a genetic thing. No, it's not. The gene mutations are an effect of the damage to the oxidative phosphorylation. We're trying to straighten this out. It's unbelievable. But when you have ideological dogma, you cannot change the brain of an ideologue. There's no way you're going to get some guy who is a devout member of one religion to immediately abandon it and jump into the other. That's called ideology. It's like a paralysis of thinking.
And we see it everywhere.
It's a paralysis of thinking. So when you have scientists that are absolutely lockstep with the idea that cancer is a genetic disease, no matter what you say, no matter what evidence you present, these guys just can't accept it as if it were some sort of a religion they're involved with. So we're going for the people. Let the people make the determination. The more and more stage 4 cancer patients that survive, they say, well, how come you're alive and everybody else is not? You say, well, I did metabolic therapy. Ooh, I want to know about that. What do you have to do? And we're writing out the treatment protocols now as we speak. So eventually clinics will be set up to do this. And more people will be surviving as the result of this. It just takes time.
I'd like to get into the particulars about those trials, but I cannot help but see the parallels between this illusion of consensus that we see in all spheres of science and professions. It's uncomfortable to have to change your mind.
Oh, yeah. It's very uncomfortable to have to change your mind and admit that you might have been wrong. And also, when you're well paid to think, it's very hard to get somebody to believe something when their salary depends on them not believing it. That was from Upton Sinclair. Upton Sinclair said that. So yeah, I mean, the amounts of revenue generation from treating cancer could be, one of the interesting things that I just found out that in the Wall Street Journal, you can find out an awful lot about cancer just by reading the Wall Street Journal. That really tells you what's going on in the cancer industry, where the stocks are up. Oh, yeah. In my cancer class, I have my students read the Wall Street Journal. You can get more information about cancer from that media publication than you can from any of the scientific textbooks. It just shows you where all the energy in the field of cancer is going. But, one of the interesting things that came out was that the attempts of the Democratic administration in the United States was to reduce drug costs, the cost of medications, because, in the United States, we pay more for medication than almost everybody else pays for this. So one of the big plans from the Biden administration was let's reduce the cost of medications. Well, one of the consequences was that is now there's the shortage of cancer drugs for the cancer field, because they said, well, if you're going to reduce the price, we're going to make less of these drugs. So what you have now is a shortage of cancer drugs. And yet when you do metabolic therapy, one of the things interesting about metabolic therapy is you don't need many drugs. The amount of drug that you need now can be 1/10 what it used to be. And it works even better. These cancer drugs will work better when administered under metabolic approach, when in a nutritional ketotic state. You don't need much drug. So actually, this could work out really well for everybody. We don't have enough drugs. The lower drugs will work even better when you have metabolic therapy. So it just takes time for people to understand all this. It's just.
That's what concerns me, though, because, I mean, you posited the theory of cancer as a metabolic disease, with a variation on Warburg's initial theory more than a decade ago. It was well read. It was picked up. It's 10 years or more later, and there haven't been sufficient trials. People are still sticking to the genetic theory. What's different now that these trials will go ahead?
Yeah. Well, you have to realize we have two issues here. One is the one I told you about. The changing institutions is not easy. The other blowback that we get within the scientific field, and the same error that Warburg made from the initial observation, was oxygen consumption. So if you study cancer, and most people do research in cancer cells growing in a cultured dish, not as much. They do a lot of work, of course, in vivo model systems, preclinical model systems, but they also study a lot of cancer research in the cultured dish. Well, if you look at the oxygen consumption of cultured cancer cells, you say they take in tremendous amounts of oxygen. Some of them, not all of them. They take in oxygen. And one of the great misconceptions, which we have now resolved, we and others, the oxygen consumption doesn't mean oxidative phosphorylation is normal. So people were looking at oxygen consumption as if mitochondria were healthy in cancer cells. Therefore, the mitochondrial metabolic theory Warburg's theory cannot be correct, because the cancer cell is sucking down oxygen at the same rate as some normal cells. Therefore, Warburg must be wrong. Now, what happened, we showed that the oxygen consumption in the cancer cell is not used for energy. It's used to make reactive oxygen species, ROS. ROS caused the mutations in the nucleus. So the cancer cell is taking in oxygen, but it's like incorrect. It's not using it for energy. So that shows that Warburg himself made this kind of same mistake. And so they got into this big brouhaha in the scientific field. Oh, the cancer cell has normal mitochondria. Oh no, the cancer cell has abnormal mitochondria. All this other stuff. So we're clearing all that mess away. We're clearing, straighten it out. Cancer cells cannot use oxygen in any way to generate. And it's not sufficient. Let's put it this way: cancer cells cannot use oxidative phosphorylation alone to survive. They have to have fermentation. They must have fermentation driven by glucose and glutamine. So the strategy for managing cancer becomes very, very clear how to do this, except that you have this. So people will say, well, I don't know if you're right. We have to reproduce. It's been reproduced there's always some non-scientific argument to say why you can't. Nobody wants to change. They want to continue to do what they do. So, but yet we have all these we have in this country, we have almost 1,700 people a day are dying from cancer every day for some bullshit kind of argument that we have solved along with Warburg. So I just find that we're sacrificing human beings for reasons that don't have to happen. But the institutions to change, it's just so hard and it's too radical for them to change at this point in time. So we must have these poor cancer patients suffer and die as the result of this conundrum.
How are you funding your trials?
My support for my research comes largely from private foundations and philanthropy. There are people on this planet that understand what I am doing, and they don't really care whether they make a buck on it or not. They just want to be part of the revolution that's coming. It's the revolution in medicine based on this that's coming. And some people say, I might want to be thought of as being a part of this change. And there's a movie coming out called The Cancer Revolution that's based largely on the stuff that we did. And now we're beginning to collect all of these so-called flukes, these guys that had all these stage 4 cancers that are all doing fine as the result of doing metabolic therapy. So, when they say, where's your clinical, I can't believe anything until you do a clinical trial. That's bullshit as well. Even if you do some of this stuff, they still drag their feet. We did it for epilepsy, and they still want to use drugs when we clearly showed ketogenic diet was to do for epilepsy. But, who's going to fund a clinical trial to show that we can manage cancer effectively with, right? I mean, who's going to step forward to do this, right? So what we have to do is we have to continue to show large numbers of people who continue to survive, and they become advocates. And then people are going to say, what did you do? How did you do that? I did metabolic therapy. And we're in the process now of writing a very comprehensive treatment protocol so that physicians will know exactly what to do and how to do it for the majority of cancer patients. The PET scan management, liquid biopsies, we can do an awful lot of things. We can dovetail a lot of the newer technologies into metabolic therapy. So we just have to rearrange some of the chairs, but we can still bring a lot of the same evaluation techniques that are currently being used into the new plan, except that now we don't have to really use such toxic and expensive poisons and things to manage the disease. And I think the outcome is going to be really, really good for managing cancers. And as far as the prevention goes, people say, "Oh man, listen, most people they don't do prevention." So it's really what you're going to do once I have cancer. Once the person has cancer, what can you do for me? And that's where the big programs are going to come in management, effective management.
So what would you just briefly recommend as preventative measures?
Well, at prevention, as I said, the origin of cancer comes from chronic damage to the mitochondria and the ability of that organelle to produce energy through oxygen. So there are any number of ways by which cancer can occur in a person over many, many years through chronic disruption of energy metabolism in some cell, in some tissue, in some organ. And as I said, if your mitochondria remain healthy, you won't get cancer, or cancer would be extremely rare, as it was in our Aboriginal ancestors and the folks that are still following traditional ways. Very rare. And as I said, Albert Schweitzer, who actually did a lot of his work in Africa, he evaluated some 40,000 people. I think Tim Noakes' book, it talks about how many people Albert Schweitzer looked. He didn't find cancer. He said, why these people have no cancer? Because they were following their traditional ways. They had a lot of exercise. They had a lot of low carbohydrate foods in their diet. And your body is so resistant to cancer. In order to get cancer, you really need to abuse your body chronically for long periods of time, because we're designed not to get cancer. Just like the chimpanzee doesn't get cancer, the gorilla, orangutans, these kinds of things. And they're under constant surveillance all the time in these zoos. And then when I went to the zoo out there in San Diego, where they have these bonobos and these other kinds of things, and I said, how come you guys, do you ever feed them jelly donuts and pizza and stuff like? Oh no, that would be animal cruelty. I said, well, they're the same genetics as we are. I said, we have diabetes, heart disease, all this cancer. We're pounding down, Big Macs and all kinds of stuff, and then we wonder why we're getting cancer. The chimpanzee, you don't want to eat, you don't want to go on a chimp diet either. You got to eat raw monkey meat and eat insects and stuff like that.
Apart from carcinogens and inflammation and these kinds of things that you can scientifically see the process by which they make you sick and get cancer, what about human beings that live healthy lives? They don't smoke, they're not drinkers, they exercise. What is the possible scientific explanation or biological explanation for them to just one day get cancer?
Well, we have to look at our environment and the environment that we're in. Most Western societies now, it's not just one thing that could produce cancer. I mean, you have a diet and a lifestyle issue. You're also exposed to all kinds of things in the environment, in natural environments. I mean, we're driving on highways that have all kinds of toxic material coming out of cars. We just have a new environment, different from our ancestral environments, like the Paleolithic time of our existence. And some of the, as I said, the Aboriginal tribes where cancer is very, very low. So what is it in our Western diet and lifestyle issues that could provoke cancer? We have oncogenic viruses. We have intermittent hypoxia, sleep apnea. We have a lot of different things combined. And people say, well, I don't know. I eat a very healthy diet and lifestyle. Well, what is that diet and lifestyle? What are your GK? What is your glucose levels and ketone levels? Well, when we evolved as a species, we were always in some level of ketosis because we didn't have any carbohydrate, highly processed carbs in our environment. So, we have things today that are very, very different. And this explosion of cancer has only happened over the last, 75, 100 years. I mean, it's not like it was always with us. We didn't just all of a sudden, hey, everybody's got cancer now. It's happening as the result of our technological environment and lifestyle that we're Western society lifestyles come into an environment and people start getting cancer, type 2 diabetes, cardiovascular disease. They're all related to the same problem, chronic inflammation.
My ultimate question is if there's a possibility that stress and negative energy and something that can biologically sort of work its way into your system and manifest physically, is that scientifically possible?
Absolutely. The chronic stress, depression, a lot of these things are also provocative agents leading to dysfunctional respiration and mental illness. I mean, there's a lot of things that could be going on here, any one of which are usually combinations of them. So it's very hard to pinpoint exactly why such and such a person may have this disease or chronic disease or that chronic disease. Mm-hmm. But, in cancer, we certainly know there are a number of provocative agents that can damage oxidative phosphorylation, that is mitochondrial respiration. And you combine that with several of the other things, and altogether, you put yourself now at risk. And then people say, well, it must be genetic because we have these inherited genes that run in families that put you at like BRCA1 mutation and some of these. But we've looked into every one of those, and every one of those damages oxidative phosphorylation in one way or another. So the origin of the cancer is damaged mitochondrial function, whether it's caused by a chemical in the environment or an inherited risk factor that you have in your genome. But the reason why it's not a primary risk factor is every time you have that insult, you always get the outcome. Like we have Huntington's disease, people who have the mutation in the gene Huntington, 100% of the people that have that mutation will develop Huntington's disease. But we have never found a mutation in cancer inherited that's 100% penetrant. Like the highest level is the Li-Fraumeni mutation, which is a gene mutation in the gene called P53. And that's about an 85% penetrant, meaning 15% of the people that have that mutation don't get the cancer. In order to get, between the primary cause versus secondary cause. Primary cause is there 100% of the time. A secondary cause may or may not be 100%. So no, we have not found any cancer gene that's 100% penetrant, meaning that the inherited mutations are secondary risk factors. Some of them can be very high, some of them can be low. Like for BRCA1, 50% of the people with the mutation develop a mutation, develop a cancer of the breast or maybe another organ. But that means about 50% of the women that have that don't. So in order for something to be a primary cause, 100%, everybody who has that has to develop. So we have inherited mutations as risk factors combined with environmental insults that can increase the probability of manifesting the condition. So you have to weigh all these things together. And every woman that has a breast tumor, whether it's from chemical carcinogen, smoking, or BRCA1, they're all fermenters. So bottom line is that whatever tumor arises from the provocative agent, the cells in that tumor will be fermenting glucose and glutamine. So you know how to manage them, regardless of what the origin happens to be.
But is BRCA not a sort of exception of a gene that you must sort of look out for? I mean, that's one of the reasons, you can test for it. But say your parent had non-Hodgkin's lymphoma. What does that mean for you?
Well, it depends on the environment that the person is in to generate non-Hodgkin's lymphoma. There might be some gene risk factors that could put you at risk in the right environment, but there's no gene that will be 100% responsible for whether or not you get non-Hodgkin's lymphoma or any cancer for that matter.
Just to close off with, can you tell me about the first step of your trial? When does it start?
Yeah, we have to write the protocol first, number one. Number two, you have to have a trained staff of physicians that understand how to do this. That's another thing. And number three, you have to have a place to do this. So normally hospitals would do this, a trial like this. But unfortunately, we have not yet found a hospital willing to do a trial the way we would want to specify it. That's because of the institutional review boards. The IRB makes a decision as to whether or not you can do something in that hospital. We know that in the brain cancer field, they will do metabolic therapy only after radiation and chemo fails, which fails all the time anyway. So they will not allow metabolic therapy to be done as a standalone. It has to be done with radiation. So therefore, we have to find a new venue to allow us to do what we think should be done. And then we have to train people to do it. We have all of this in our treatment protocol. Once we have the treatment protocol published, then it becomes a how-to manual on how to start this. And then we need to train the physicians to know the concepts behind this. What are they doing? Why are they doing it? What should they be looking for? How can we modify the plan when we see things arise? It's not like one shoe fits all. Patients have to come in. We do blood work. We figure out how healthy they are. A lot of folks that have cancer have diabetes. They have high blood pressure. They have hypertension. They have all kinds of other issues. You got to start managing some of those things before you can start using the kinds of drugs that will be selectively killing tumor cells. So there's a lot of things that go into this. But we have to write the protocol first. We have to let people know, if you see this and you see that, what do we do? How do we do it? At what point does the patient now receive the kinds of drugs, dosage, timing, and scheduling of these drugs that work together with the diet? So I'm just giving you a kind of a snapshot of what's going to take place eventually.
Yeah. This may have been quite a few years ago, but you were quoted as saying that you would use chemotherapy alongside metabolic theories. Is this no longer the case?
No, I think we can still do that. I think that, as like I said, we can use far, far lower dosages. See, they have standards that that are instituted almost everywhere in major cities and around the world. You have to have, if you follow a protocol for cisplatin or these other drugs that they have, lumistine and whatever else, there's a dosage range from the lowest to the highest. But I think those low doses can be lowered much more than what they recommend. We don't need, especially if the patient is in therapeutic ketosis or water-only fasting. These drugs will kill cancer cells for sure, but you want them to kill cancer cells more selectively than harm your normal cells. And that's why when you transition the body to nutritional ketosis, you give the drugs a greater opportunity to kill the tumor cells with less toxicity. So that's another phase of where we're going. And that's why we don't need much of these chemotherapy drugs. You just need a little bit of them, knowing when to use them and how to use them, at what point. Even immunotherapies, like if we have a raging tumor in a brain or a colon or a lung, and we bring it down to a small, tiny little spot, and we know that all the cells in that spot will have something in common because they were able to survive metabolic therapy. You might now be able to come in with a drug or an immunotherapy and knock them off real quick. You just don't do it at the beginning. You just have to know how to use the tools that you have. And right now, we don't know how to do that. And we're trying to tell people, we can help you learn how to do this in the best way to achieve the greatest outcome.